Hi everyone, this is coming to you from Education for All. Correct. We are still on infinitesimal calculus and we are now looking at video number 4. We have reached a position wherein we want to look at limit, what a limit is. Limit. From our previous video. Why we need this limit? Something I would like to mention now is that in space, motion is constantly changing. All these things you have in space, the motion changes at every instant, constantly changing. So the idea of average, for example, average speed, like when you are driving on the road, your car, you calculate the average speed. This average speed, it's useless in space. It's very, very useless. Calculating average speed, average velocity. These things, when you space technology, they become very useless. They are not considered because force vary with position and time. See that? So in that case, if we have this kind of graph, we say here is x, and already we know this is f of x here. This is f of x. If we increase this, if we take this point here is f of x. So now this distance here, if this distance is h, for example, so this will be x plus h. If we say this distance here from here to here is h, so now this will be x plus h. So now what will be your f of x here? So your f of x here will be f of x plus h. Correct? That will give us f of x plus h. So now we want to find the gradients. Remember when we have this straight line graph before, you want to find gradients. We said gradients, which is m, we'll give it letter m, is rise. Rise simply means this one here over the run. Run means on the x-axis. This is run. So rise over run. So the same idea I want to bring on this curve. This is a straight line. I want to bring it on this function here. Right? But in fact, here we are looking at second from what we have. We have explained this graph here, you see, this diagram you see here. We are looking for the gradients, not the gradients of a line, because the gradient to the tangent of a line, you see it touches the point. We are not looking at this one here. This one has 2 points. This one here is 1 point, but here you see it's 2 points. It's 2 points. So in fact, you are looking for the gradient of the secant. So call it MS, SECANT. We are looking for the gradient of these lines. They all have 2 points. So the gradient of these lines, which is the rise, when we say rise, if this was y1, this is y2, this is x1, this is x2, so you will have the rise, m is equals to the rise, which is y2 minus y1 all over x2 minus x1. That's what you get, the rise over the run. Increase on the y-axis divided by increase on the x-axis. right? So what do we get here? The rise, which is f of x plus h minus f of x divided by, which is x plus h minus x. Yeah? F of x plus h minus f of x. So here we can do something here. This is x plus h minus x. So you know, if you open these brackets, so we'll have x minus x. So only h will stay at the bottom here. Let me leave it. We don't confuse people. So m of s second is in fact f of x plus h minus f of x divided by h. Now I've done that one there. So let me come here. I will leave that diagram. It's very important. Now we are looking for the gradient of secant, but we don't need the gradient of a secant. We need the gradient of a tangent. When it just touches the graph, we need the gradient of a tangent. That is the gradient of a tangent. Let me just say this, T-A-N-G-E-N-T. So the gradient of a tangent, what does that mean to you? That is when this distance keeps decreasing, 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 when it is approaching almost to this tangent line. But we say when it's approaching to that point we want, that is when it is approaching to zero. Remember when we talk about instantaneous speed, it's zero there. So it's when that point, when these intervals are approaching to zero here. This point here is zero, instantaneous. Something instantaneous is zero there, time is zero. If you are talking about distance is zero there. So when it's approaching to zero, that is, we have now the tangent here as this h. We're now talking about limit of f of x plus h minus f of x all over h as h tends to 0. That is when this interval keeps reducing, approaching to 0. So in that case, we are in fact talking about gradients. Gradients. The moment it approaches to 0 is gradient. Gradient. That is what we are talking about. But we know this cannot be 0. It's when it's approaching to 0. So this, in fact, this idea, in fact, it's what is called the first principle of calculus. The first principle. The first principle, I'll just say first here, principle of calculus. This one you see here, this formula here, the next video, we shall be solving problems. And then we shall be using this first principle of calculus. And then you will see how this function here, or this principle here, is very, very important in calculus. This is the topic limits now. And this is the backbone of calculus. This one you see here. Without this one, calculus will not work. Thank you for watching. Bye-bye.